Next, we're going to get to polysaccharides. And again, poly just means many. So many simple sugars put together. And this is going to be my first example of like one of my favorite structure-function relationships. And that has to do with this structure right here, which we'll just call glycogen. Glycogen in animals is a bunch of glucoses all connected together, right? This is good. Glycogen is good to have in your body because if your blood sugar, for example, goes too low, what can happen is your body can stimulate glycogen to start breaking down, releasing glucose into your bloodstream, right? In fact, if you're ever in a situation where you're stressed out and you release some cortisol, that stress hormone, one of the things that cortisol does is it starts releasing, breaking off glucoses from a glycogen that you have in your muscles, glycogen that you have around your vital organs, so that you have a nice level of sugar to support your system, especially if you're stressed out, right? So where does the structure-function relationship come into this? Okay, let's think about starch first before we do this. You might have heard of starch, right? Like potato chips, right? You need something starchy. When you think about the difference between starch and glycogen, it's not in what they're made of. When you eat a potato, you just got a bunch of glucoses connected together in a string, in a single line, maybe a couple of lines. Glycogen is the same glucose, but instead of connecting it in a line, you have these branching patterns. That's the one major difference between glycogen and starch. Why does that matter? It's because when you do a hydrolysis, you can only break off these carbohydrates at the ends, right? So if I have all of my glucose in one long line and I store that in my body, that sucks. Why? Because I can only break off glucose here and here, and that's slow, right? If your body needs sugar, if your brain needs sugar, you want to be able to release that sugar from the stored glycogen as quickly as you can, right? Being hypoglycemic under the amount of sugar that you should be at is very dangerous, right? It's one of the reasons why you might be wearing a continuous glucose monitor to see if your blood sugar is going too low, right? That could be fatal. So you want to be able to release a lot of these glucoses as quickly as possible. How do we do that with glycogen? By having branches. Because if you have a branch, check this out. You could break off this glucose the same time you break off this glucose, the same time you break off this one, the same time you break off this one, and that one, and that one, and that one, and instant glucose into the bloodstream, right? So that is a structure-function relationship. The structure being the branching, the function being the quick release of the stored glucose you have.